Hi, welcome to your Kaplan lesson on strategic guessing. I'm Sam Fallon. We're going to explore together how you can take a look at a question and its answer choices, and even if you don't know the answer, still be able to have a strategy to at least maximize the ability to get that question right, given that you might not know exactly how to answer it. It's good to have a strategy for it, and that's the purpose of this lesson. So, the main learning goal of this lesson is to be able to choose the answer that's most likely to be correct, given that you might not actually know the answer. We're going to show you a couple of questions that you might know the answer to given these science topics that you see here. We're mostly doing organic chemistry here with the alcohols, aldehydes and ketones, carboxylic acids and their derivatives, and finally some molecular structure and absorption spectra. But then we'll also cover some questions that you can't have known the answer to because they're from a passage, and we're not going to give you the passage, we're just going to give you the question. You would need to look up information in the passage. So the idea behind those questions is that you would get the real experience of having to guess on the test because you wouldn't know the answer. So that's what the questions are going to look like. Remember, when you're going through these questions, the goal isn't to get to the right answer. The goal is to understand the strategy that you need to be able to guess on the test. We want to make sure you have a strategy for that moment on the test when you make the guess to maximize your points, even though you don't know the answer. So let's go ahead and jump into this learning goal about how to best strategically guess on the test. Starting here with number 1, we can see that there's a lot of variables in this question, and the answer choices are all numbers. So we can tell this is going to be a math question, maybe even a longer math question, because we have some logarithms in here that we might have to take. We're given this equation. So the first thought we have is we should probably do long math problems last. When you put questions last, sometimes you're completely running out of time on the test and you just don't have time to do a lot of math. So the next step would be to figure out what makes each answer unique. And looking at our answer choices, we can see that the mantissa, or the first number in each of the scientific notation answer choices, which is also known as the significand, is different. A, B, C, and D all have different numbers in the front. So if we can at least do some math to try to figure out which one of those is going to be the closest, we can at least stop our math earlier than we would have stopped it otherwise and make a pretty educated guess without having to do the math all the way through. So this is a strategy here. We're trying to take a guess at something with only doing some of the work. You can be running out of time on test day and still want to get this correct math answer. So like we said, the mantissas are all unique. And we can go through the math here. We'll set the two equations with common variables equal to one another. Then we'll plug in the numbers, and we're trying to solve for the concentration C, as we can see in the problem here. So we set the equation up for that. We got 9,000 C equals 1, and our final answer, and where we should stop doing the math so we can start guessing, is C is 1 over 9,000. But 1 over 9,000 does resemble the fraction 1 over 9. So if you happen to know what 1/9 equals, you might be able to guess based on those mantissas, because we realize there's only one answer choice that's going to work for us. If we know there's got to be ones in our mantissa, answer choice B is what we have for that. So there you go. That's some strategic guessing when you're running out of time and there's a lot of math to do in a particular question. You can stop the math a little bit early, get to your answer, and move on. Let's go ahead and move on to question 2. In this case, the mantissas are a little bit closer to each other. We have that 149 and we have the 152. So that's going to be a little trickier to distinguish, but we are trying to figure out what makes each answer choice unique. And looking at our answer choices, the exponents are somewhat unique here. 1, 2s, and 3s in there. If it comes down to a 2, we'll have to take more of the math, but we might as well look at the exponents first, try to at least get some of the math out of the way, and try to make a guess. So we'll start doing part of the math at least. We can first look for units that cancel, and we can plug in the numbers, and we get something that looks like the equation on your screen. We're again solving for C, so we do the algebra to get that, and eventually we see that C equals 7.8 over 52.5. Now that's not the most wonderful fraction to have to do in your head on the test, especially when you're running out of time, so we're going to now look to scientific notation. Here's what we mean when we say scientific notation. That 7.8 could be times 10 to the 0, and the 52.5 can be changed to 5.25 times 10 to the 1. What we realize about this is that we've got a 10 to the 0 on top and a 10 to the 1 on the bottom. If you do that exponent math, you know that C has to have a 10 to the negative 1 in its answer. We don't really care about the mantissa here, we know what the exponent should be. This saves us a little bit of time and gets us to the only answer that can work, which is answer choice A. This shorter way of doing the math happens to work because the mantissas, once divided, give a number that just has digits in the ones place. You don't have to move the decimal point around to get the proper scientific notation, so just looking at the exponents works to get the answer. So that's what strategic guessing looks like in the context of math estimation. Let's take a look at a different context. In number 3 here, some of the answer choices imply something that can get us closer to an answer by strategic guessing. So let's take a look at the problem and see how strategic guessing works here. So let's take a look at this problem here. We're given the chemical composition of ricinin, and we're also given an IR spectrum from some unknown compound. Then the question is asking us, does the IR spectrum happen to match the chemical ricinin? So when we look at our answer choices, there's something interesting to note. Answer choice B and answer choice C are opposites of one another. B says yes as confirmed by the absence of the peak, and C says no as confirmed by the absence of the peak. These answer choices now are exact opposites. So if B is right, C can't be right. If C is right, B can't be right. Now, exact opposite answer choices aren't always going to give you the correct answer between the two of them. They could say both be out of scope. But when you're having to strategically guess anyway, and you happen to see two answer choices that are exact opposites of one another, that's a great place to start to try to make your strategic guess. So taking a look at answer choice B and answer choice C, you really could just guess between the two of them and move on. Because like we said, the correct answer is often one of these two opposite choices. It's just a thing about the test, because if one's true, the other can't be, and vice versa. Now, if you did happen to remember that the carbonyl group in an organic molecule does have a sharp peak at 1750, you could look at the IR spectrum and realize that that sharp peak at 1750 isn't there. However, our ricinin chemical does have a carbonyl peak, and so the answer does end up having to be C. No, that absence of the peak tells us that this IR spectrum is not for ricinin, but you'd have a 50-50 chance, even if you were guessing between B and C, to get the answer right. Again, these answer implications are just another strategy that you can use to try to guess the correct answer if you're in a situation where you're not sure what the answer is. Moving on to numbers 4 and 5, these two questions are taken from a passage, and you don't have the passage here on the page, so there's no way that you're going to necessarily just know the correct answer because you'd have to go back to the passage. Questions 4 and 5 really simulate being in a situation where you have to guess on the test, and that's why we find questions 4 and 5 in this particular lesson. So the idea here with questions 4 and 5 is that there are going to be some answer choices that happen to be similar. Take a look at number 4. You don't even really have to read the question, just look through the answer choices and try to find something that's equivalent. If you're looking at answer choices A and B, those are the equivalent answers. If lysine amino group protonates, and that makes it more nucleophilic, that means the same thing as garnering nucleophilic quality by attaching a hydrogen ion to lysine. Those two answers say the same thing. Since they both literally mean the same thing, neither one of them can be correct. To have a correct answer, it has to be distinguished from the other three answer choices. So A and B can actually be eliminated. So A and B can be eliminated. We are eliminating them because they illustrate the same thing. Then you're down to answer choice C and answer choice D for guessing. Answer choice D does happen to be the correct answer. You'll see this question and understand why it's correct as you do your homework for this lesson, because this question appears with its passage in the homework. Let's take a look at number 5 to see another example of something where we can eliminate answers just based on what they say. So again, you don't really need to read through the question so much, you more just need to look at the answer choices and find the equivalent ones. If you're looking at answer choices B and C, you have the correct idea here. A condensation reaction means that water will be a product of a reaction, water will come out of the reactant. And answer choice C also says the same thing, that water has come out of the reactant and the product doesn't have that water in it. So answer choice B and C, again, mean the same thing, so they can both be eliminated. We're back down to a 50-50 choice, and you'd have to guess between A and D. A does happen to be the correct answer, and again, find this question in the homework for this lesson for a full understanding of why A is correct. So there you go. Sometimes answer choices are so similar that you can eliminate both of them and be able to get yourself at least down to a 50-50 choice on test day, saving yourself some time and strategically guessing in the most efficient manner. Number 6 shows us another situation in which some answer choices can be eliminated and then further guessing can happen from there. In number 6, we're plotting vapor pressure against temperature, and the question's asking about boiling point. Notice, though, the most important word in the question stem is lowest. So what kind of answer is the question looking for? Well, given that it's asking for the lowest boiling point, it's looking for some extreme answer. In this case, an extreme low answer. What this means for you on test day is there's immediately two answer choices you can get rid of. The intermediate choices. We're either looking for the lowest temperature at some vapor pressure or the highest temperature at some vapor pressure if there is an inverse relationship going on, but we definitely know that it's not going to be anything in the middle. We see ethanol and water are right in the middle of this chart, and so ethanol and water can be eliminated from our answers. Now this one, if you happen to know how to do it, you can carry the reasoning all the way through. If we're looking for a boiling point, we know one definition of boiling point is where vapor pressure equals ambient pressure. Our ambient pressure is 0.5 atmospheres. If we look at the diethyl ether, the 0.5 ambient pressure and the vapor pressure would give us a lower boiling point. If we carry that line all the way over to the iodine, we see that when vapor pressure and ambient pressure are the same, the boiling point is going to be a higher temperature, and so A does end up being our correct answer. However, even without knowing what this problem is asking, you could still at least get your choices down to 50% chance of getting it correct by being able to eliminate the extremes. Let's see another question where we might be able to eliminate some extremes. In this question, they're wanting to know how many ketone groups we form, and we're using some big organic chemistry molecule and ozone. So this is going to be an ozonolysis reaction. Even if you don't remember the ozonolysis reaction, you might know that ozone is a pretty reactive chemical, and so it makes sense that maybe some ketone groups could form. However, it's unlikely that tons of ketone groups are going to form because there's just not double bonds, as you can see here, where the ozonolysis reaction, you might remember, is likely to occur. So therefore, an answer like 15 is way too high because we're just not going to get that many ketones in the product if we only have these 4 double bonds to start with. What we're getting at here is that 0 and 15 in the answer choices are fairly unlikely, and there are extremes that can be eliminated. This gets you down to either 5 or 8. From there, you can look at all the places where ozone reacts with this molecule. You can maybe recall that ozone reacts with carbon-carbon double bonds to form 2 carbonyl groups and figure out which ones of those are ketones. But you might be realizing this is actually just a long question in and of itself, regardless of whether you know your organic chemistry. And so it might just be good to guess B or C on this one, maybe mark it and come back to it later if you have extra time. For your reference, however, just in case you do want to figure this one out, the correct answer here happens to be 5. The products of the reaction are 5 ketones, 1 aldehyde, and 2 carboxylic acid groups. Again, the main takeaway here from questions 6 and 7 is you can look at a question like this and easily eliminate down to 2 answer choices and have a 50-50 chance of getting that question right, even if you have to guess. Another type of question, which you can do a lot of strategic guessing on, is a Roman numeral question. There's a Kaplan Roman numeral strategy, and the strategy works by looking in the answer choices and seeing which are the most commonly occurring Roman numerals. In our case, if you check out the answer choices, Roman numeral 1 and Roman numeral 2 actually show up the most. Those are the Roman numerals, therefore, you want to evaluate first, because if one of them's wrong or they're both wrong, you won't even have to look at Roman numeral 3 and you'd be able to get to your answer. So you take a look at Roman numeral 1 first. It says that compound A has a conjugated pi system. So to evaluate that Roman numeral, you'd have to go back to the passage, take a look at compound A, and see if it really does have that conjugated pi system. Then, depending on if Roman numeral 1 was true or false, you'd either eliminate or keep any answer choice that says Roman numeral 1. Then you'd move on to Roman numeral 2, and only if you had to, move over onto Roman numeral 3 until you have only one answer choice remaining because you've eliminated everything else. Now this problem is pretty unique in that it happens that Roman numerals 1 and 2 say the same thing, scientifically. If compound A has a conjugated pi system, it also happens that it must be true that adjacent carbon atoms must have unhybridized p orbitals. And so actually, there's an extra little bit of strategy you can use on this particular problem in that Roman numerals 1 and 2 either both have to be in the answer choice or neither can be in the answer choice. So you can technically get rid of answer choice A and answer choice C because they both don't happen to have Roman numerals 1 and 2 in them. Then you'd simply guess between the remaining answer choices and you'd have a better chance of getting it right because you've narrowed it down to a 50-50 choice. And that's the Kaplan Roman numeral strategy plus a little bit of guessing that you should use on test day. So now we're going to move into questions 9 and 10. And questions 9 and 10 actually go with a CARS passage, and you can see the passage excerpt at the top of the page. Now, this is a session mostly dedicated to science, but strategic guessing can happen in the CARS section as well, so it's definitely something that needs to be covered in this lesson on strategic guessing. Take just 1 minute, read through this passage excerpt, and then we'll go over how to strategically guess in the questions. This passage excerpt is about non-therapeutic experimentation, and it looks like it's controversial, but it's also generally accepted. There's some details about volunteers, and especially risk for human volunteers. Finally, there's some information about safeguards. We can tell that there's plenty more to this passage that probably explains some things about experimentation and these safeguards, but the passage excerpt is what we get to again mimic that experience on test day of maybe not understanding part of a passage and having to guess on a couple of questions because of that. The idea here is get as much information as you can out of the passage and then use that to answer the questions. So let's look at these questions. In question 9, we're talking about therapeutic and non-therapeutic experimentation. And we remember from the passage excerpt, we only had been talking about non-therapeutic experimentation. So this passage probably talked about both therapeutic and non-therapeutic, but what we were able to get out of our passage excerpt was the information about non-therapeutic. And question 9 can be answered by strategic guessing using the tone of the author. So think about the tone of the author. That's a strategy that's being shown here, to understand the author's tone and be able to work through these answer choices. So think about the author's tone. Was it positive, neutral, or negative? The tone of the author is fairly neutral overall in the passage excerpt. So therefore, we can eliminate any answers that are inconsistent with that neutral tone that the author has. Look through the answer choices and see which one you can eliminate because they're not neutral enough. If you're looking at answer choice B and D as being too extreme, you're looking in the right area. The author is fairly neutral about non-therapeutic experimentation, saying the author thinks it's a relic of a bygone era or not consistent with conventional medical ethics is just a little bit extreme. And you've got yourself down to answer choices A and C, and from there you can guess, giving yourself again that 50-50 chance of getting it right on the test, despite having to guess. Number 10 is specifically about non-therapeutic experimentation, which is what our passage excerpt was about, so we do know a little bit about it. We can go back and look at what the author said about it. We see that the author said it's controversial, but it's also generally accepted. So we're looking into our answer choices, and again, we're going to eliminate anything that doesn't go along with those two guidelines of it being more controversial and yet generally accepted. Answer choice C has the words completely opposed to it. That's going to be too extreme of an answer. Answer choice D has that word appalled in it, and again, that's going to be too extreme of an answer. We've eliminated our extremes, and then we can get down to answer choices A or B for guessing. So there you go. If you're stuck on the test and you have to make a guess, now you know several different strategies that you can use to get closer to the answer and increase the probability that you're going to get that question right. This review covers some aspects of questions and some aspects of answers in which strategic guessing is going to give you a little bit better of a chance of getting the correct answer. Further along in the review, you see that there's test-specific situations like running out of time or guessing would get you the answer faster. You can also look for when you're making those decisions to strategically guess in the test. Great job on getting through this lesson. Now you're armed with even more strategies to be able to tackle that MCAT and even answer questions that you're not exactly sure the answer to with a higher probability of getting them right. Keep up the great work and best of luck in your studies.